In this tutorial, we're going to talk about a lot of concepts that are very useful in thermodynamics. The first one that we're going to be discussing is state versus path functions. And there are three kinds of energies that are dealing in the first law of thermodynamics. Remember that the first law of thermodynamics states that Q minus W equals delta U. And the heat and the work are functions that depend on the trajectory. Work is very straightforward because you remember that the thermodynamic work in a PV diagram is depending on the trajectory, it's the area below the curve. So if I go through this trajectory or through this trajectory or whatever, the area below the curve is going to be different. So this is a path function. Heat is exactly the same. It depends on the trajectory. But if I start from one point and I end up at another, if I start at this point and I end up here, right? For the change in internal energy, it doesn't really matter. So that is going to be a state function. It only depends on where I start, where I finish. If I start here, right, or I do this process, right, well, this is not going to change because the change in internal energy is going to be final minus initial. The isochoric process is the one where the volume is constant. So in a PV diagram, it will look like a straight line. The pressure can change, temperature can change, but the volume remains constant. In that sense, the work is going to be equal to 0. And in the first law of thermodynamics here will express that the heat minus 0, which is the work, is going to be equal to the change in internal energy. And in this process, it is interesting to state that is going to be mass times the heat capacity at a constant volume, which we're going to state as Cv, times delta T. Well, this is in the integral form, actually. And if the C is constant, which is not. So at the very end, this is going to be equal to mass integral of a function of Cv, which depends on temperature, dt, which is the differential of temperature. Now, since the change of internal energy is not depending on the trajectory, but only on the state, it will only mean that it will always be m integral of Cv dt. That's going to be always the change in internal energy, which is the heat in an isochoric process. In the isobaric process, the pressure is constant, which will mean that you will see a straight line, but in this case, it's a horizontal straight line. And the work is going to be equal to P delta V. In this sense, then the first law of thermodynamics will express that heat minus P delta V is going to be equal to the change in internal energy. And in this case, if we pass P delta V, we can say that heat is going to be delta U plus P delta V. Now, U plus P delta V is going to be equal to the enthalpy. We're going to be defining this as the enthalpy, and it is going to be equal to mass integral of Cp, which is the heat capacity at constant pressure, dt. Cp is also a function of temperature, and enthalpy is going to be also a state function, which will mean that it only depends on the final an initial state. Cp and Cv are very related, by the way. Cp is going to be equal to Cv plus R, which is the ideal gas constant. The isothermal process is the one where the temperature is constant, and it looks like this in the PV diagram, which is an isotherm. And the work here is going to be equal to nRT natural logarithm of the final volume over the initial volume. Now, this is by doing an integration with an ideal gas. So, since the temperature is constant, well, delta U, which is the integral Cv dt, right? Since the temperature is not changing, is going to be equal to 0. So in this case, the heat is going to be equal to the work, nRT natural logarithm of V2 over V1. There is also a very special process, which is called the adiabatic process, where the heat equals 0. Here, the first law of thermodynamics is going to be minus W equals delta U, which is going to be M integral of Cv dt. And it is very important here. We can define a constant which we call gamma, which is equal to Cp over Cv. And here we will have a special process where we will say that Pv to this gamma, only V is elevated to the gamma, is going to be constant. So in any case, we can say that P1, V1 to the gamma is going to be equal to P2, V2 to the gamma. With this relationship, we can also get that the work is going to be equal to P2, V2 minus P1, V1 over gamma minus 1.